Okay, part 6. Part 6 of this video tutorial series is going to revolve around question 31. Now, question 31 has to do with relationships. In other words, if one variable increases, does another variable increase, decrease, or stay the same? Okay, and by what value might it increase, decrease, or stay the same? So let's take a look. So in letter A, we're given functions at the top, by the way. The first function says that z is equal to some value x over y. Then we're given c is equal to a times b. We're given L equals m minus n, and we're given R equals s squared divided by t squared. So letter A says x increases and y stays the same, or y stays constant, z does what? Okay, so what we're going to do is we're going to write that down. So z equals, now x is increasing. So we're increasing our x. X is increasing, divided by y, which is staying the same. So if that's true, if x is increasing, if the numerator is decreasing and the denominator is staying the same, that means z must be increasing. Okay, so z increases. Okay, now what if y increases and x stays the same? So here's our function. This time the denominator increases, but the numerator stays the same. Well, if the denominator gets bigger, that means the whole fraction gets smaller, so z would decrease. Okay, now what happens if z stays constant? It says if x increases and z stays constant, what happens to y? Okay, so z equals x over y. So it says x increases, but z has to stay the constant. Well, the only way that z stays constant is that y has to increase as x increases. That's the only way for z to stay the same. So y must also increase. Okay, this is called proportional reasoning. Okay, now the next three, D, E, and F, revolve around this function here, C equals A times B. So C equals A times B. So it says as A increases, so if A increases and C stays the same, what happens to B? So A increases, C doesn't change. That means in order for two numbers to multiply A and B times each other and get C, and C does not change, B must have to go down as A is going up in order for C not to change at all. So B would be decreasing. Okay, letter E, as C increases, as B stays constant. So C equals A times B. We are told C increases as B stays constant. So I kind of put an X through things that stay constant because it reminds me not to include that. But what has to happen? If B is staying constant and C is increasing, then that means A must be increasing also. So A must be going up too. Okay, and the last one for this section, we have C equals A times B. This time we're told that B is increasing and A stays constant. Well, if that's true, then C must also be increasing on the other side of the equal sign. So C is increasing too. Well, the next two letters, G and H, are dealing with this function here, L equals M minus N. So L equals M minus N. All right, so as N increases, if N increases and M stays constant, what happens to L? I want you to think about this. If you're increasing the value of N, in other words, N is a bigger number, then aren't you subtracting less? So if you're subtracting less, that means L, which is the difference is going to be less. Therefore, it's going to decrease. Okay, so then we have L equals M minus N. It says, as L increases and N stays constant, what is M? It might help you to solve for M first. That might help. So if I add N to both sides like this, I get the fact that M is equal to L plus N. We are told that N stays constant and L increases. So if L increases and N has to stay constant, that means M must also increase. So it's got to go up too. Okay, now the last two letters, I and J, are all about this last function. R is equal to S squared over T squared. Okay. All right, now this time we're doing it wants to know some, like proportionally speaking, how much bigger or smaller is it, okay? Now, we can do that by replacing, if a variable is tripled, we can replace it with the number 3. If a variable stays constant, we can replace it with the number 1, because when you multiply by 1, you don't change anything. If something was doubled, like t is doubled, we're going to replace t with the number 2. Okay, so that's how we're doing this. So s is tripled, t stays constant. So what this becomes is s is tripled, so 3 squared over t stays constant, 1 squared. Okay, well, 3 squared is 9, divided by 1 squared is 1, 9. What this means is r is 9 times larger. That's what this means. That's what 9 means. 9 times bigger. Okay, now we're going to do the same thing. R equals s squared over t squared, but this time t is doubled and s stays constant. What is r? So this time s is staying constant, so I'm going to put a 1 squared there, over t was doubled. I'm going to put a 2 squared down here. So that's 1 over 2 squared is 4. That means r is 1/4 as large. You could say it that way. Or you could say 4 times smaller. To be 4 times smaller is 1/4 as large. This type of proportional reasoning is going to be really helpful when we study geometric optics and we study the magnification of images from mirrors and through lenses.